Howdy folks, welcome to part 6 of my electrical age tutorial series. Today we're taking a break from the boring super flat classroom to show how bases are made. Now right here we've got this basic old base. There's nothing special with it, and it's one you might find in your neighborhood Minecraft area, but we're going to make it special. We're going to electrical age it. Now I like to put all my electrical age and electrical stuff down the basement. Gets it out of the way, and I think it looks better surrounded by stone than it does, say, on the second or third floor. Now to start off with, anytime you're doing wiring, have your meter. It will allow you to see where electricity is going, detect early high voltages, keep track of power, and generally a good thing to keep in hand. To start off with, we're going to create a power source to get rid of that torch down here. So let's get some heat furnaces, a turbine. Going to need a cooler for that. Let's get some combustion chamber upgrades while we're at it. No reason to be stingy and creative. Going to need some coal to power those. And I think that's it. So let's put these guys here on the back wall. There we are. Add a couple of turbines. Oop, only one. And some dissipators so they don't overheat. Take these guys, give them coal combustion chambers, switch them to external because we're going to control them externally instead of through a regulator. And we are done. One other thing you might want to consider is a hopper system. You can actually use hoppers if you point them to the furnaces to feed coal in them. As an example, if I take the coal out of that guy, put him in the hopper up here, he'll start feeding it down to that furnace. Note that the hopper won't feed if this guy gets unchunk loaded, but the furnace will still run, which means between the time your chunk unloads and the time you get back to it, you have 64 pieces worth of coal or whatever fuel you choose to put in there. Anyways, to keep those furnaces regulated and running correctly, I'm going to need a couple of electrical probes, a signal box. Where is that signal box? There he is. Going to need some signal cable, obviously, some medium voltage cable to get the power off of that, a hub because things get crazy, and some redstone for those signal box equations. I'm going to measure two things off of this circuit. First off, I want to know how much power those suckers are going to create. Second, I want to know the voltage on the line system. If it drops too low, they need to create more power. If it gets too high, they need to create less power. Anyways, so let's start with voltage. Right now, I want the voltage on this entire system in this base to stay between 200 and 220 volts. Put those equations in there. So this probe will output 0% if the voltage is at or below 200, and will output 100% if the voltage is at or above 220. This one here measures power. Now these turbines produce a nominal 500 watts of power, so the nominal with two of them is 1000 watts. I want them to continue to produce between those nominals because that's when they're the most efficient. So if they are producing below that nominal amount, they need to kick it up a notch. So I'll set this to 900 up here and this to 1100 down there. If they're producing 900 watts or above, this probe will output 100%. If they are producing 1100 watts, or 900 watts or below, my mistake. If they're producing 1100 watts or above, it will output 0. If it's 900 watts or below, it will output 100. This is an inverted probe, but these are handy to feed directly into stone heat furnaces and other regulation things. Anyways, give them a voltage cable, validate so the equation stays, and hook those up to a signal box. Add some signal cable with that. Add some signal cable with that. Signal box there. Route that around there. Okay. So this signal cable goes through these hubs and over here. We want the output of the signal box to hook to that. If you hold down C and right click, the signal box rotates its inputs and outputs. The black one is output. It should be going to the stone heat furnaces. This right here is a green one. This green one goes to my voltage probe. The red one, which you cannot see but I know is down there, goes to this power probe. And the blue one goes to nothing. You note from the tool tap, the red input is A, the green input is B, and the blue one is C. So the voltage is B. So I'm going to use the RS equation. That's short for reset set, or basically turn off, turn on. I want the furnaces to turn off if the voltage is greater than, let's just say 215. So the green one, which is B, if B is greater than 0.75, or 70 is less than 0.25, okay. So if voltage B is greater than 0.25, and since that probe runs from 200 to 220, 0.75 is going to be right about 215. So if it's greater than 215, reset it, turn off the circuit. If B is less than 0.25, or in this case B is less than 205, cut the circuit on. Now the reason I have the power probe is because if this circuit is cut on and the turbines aren't producing a lot of power, they're doing it inefficiently. So they need to get off their butts and produce more power. This A here, because it's inverted, will make the turbines produce more power if they're below the nominals or less power if they're above the nominals. So this cuts it on and keeps the turbines producing their nominals and most efficient until the voltage gets up where it needs to be. So hit the enter key, put the redstone in, get out the meter. Note how those voltages are going up. When it gets over 215, they should cut off. And they do. So 216 volts, that's right where I want it to be. 0%, nothing going to the furnaces, and they're shut off. Awesome. So, let's get rid of this torch here and put some nice overhead lighting on this place. I'm going to hook this guy up here. And let's see, for overhead lighting, I like to use these fluorescent lamp sockets down in the basement. Also going to need some bulbs. Let's get some 200 volt economic bulbs because I don't want to use a bunch of power. And hook these guys up. Put that guy there, and this guy right about here. Okay. So I'm going to rotate those. Again, if you hold C and right-click things in this mod, they rotate. Remember that. And I'm going to run the cable to him. Note, though, that the cables to these guys aren't connecting. You have to right-click the lamp and open the GUI. Now, I don't want these guys powered by lamp supply. I want them powered by the cable. You're also going to have to give them a cable in order to use the cable. Give a medium voltage cable, get a 200 volt economic light bulb, and boom, he cuts on. Same thing for this guy. Switch him to powered by cable, give him a light bulb and a cable. There we go. Goodbye torch, we are now fully electric in this house. Now this is all fine and dandy, but what if you run out of coal? You certainly don't want to sit in the dark. Best piece of advice here is to keep up some batteries as a backup system. So let's get some batteries. I'll just use basic cost-oriented batteries here, but you are welcome to use whatever you want in your own base. And I'm going to need a ground cable to hook them up. Note the way the battery is depicted in your hand. Note how the black little part is on the right side. This means that whenever you place the battery, the negative will be on the right. Please do not place the battery like this and have the negative be on the right and go to a 200-volt cable. You will blow up your entire setup and have a bad time. So, make sure to place it where the negative on the right goes away from the high voltage cables. Better yet, I like to simply put a ground cable down and place batteries off the ground, where they are much less likely to blow up and misbehave. I'm going to have to break my wall to get to that section. Alright, so 50, since these are in series, now it's now at 100, 150, 200 volts. Get my stone wall back there. Alright, and connect these up. Boom! No explosions, everything is good. Those batteries are charging like they should. Note that they're charging a little bit high. This is because the voltage on the line is already high and the batteries are relatively empty. This should eventually not happen as the batteries get fuller and fuller. Alright. Now we've got batteries. What else can we put down here? There we are. Let's get some machines down here. Let's get a plate machine, a compressor, a magnetizer, and a macerator. Alright. So I think I'm just going to line these up right next to the battery bank. Plate machine, a compressor, and a magnetizer. There we are. Now please be careful when wiring around those ground straps. If you were to mistakenly, say, put this guy on that, and then forgetfully put a 200-volt cable there, you would be shorting a 200-volt cable to ground, which is bad. So please don't do that. Anyways, let's hook these machines up. Note that that has 0 volts. Again, 0 volts. Now he has 206 volts. Alright, so you actually have a little bit of space left here. Don't know what you'd put in it, but you have a space. Maybe some chest full of dirt or cobblestone or fancy ores. Anyways, this is all well and good, but you're still running off coal. Let's go change that up. Now up on the roof here, we have the option to put solar panels. Don't think it needs to rain. Anyways, so solar panels are nice because they will create a whole bunch of electricity in the daytime, which you can store, assuming you aren't bad with managing your electricity and leave your lights on in your house all the time. And you can use that electricity to run these machines we just put down there. Or nighttime lights. It all depends on how much you get and how much you need to use. So, for solar panels, let's get the panel, a ground cable. We're going to need some solar trackers because we want to make it fancy. Going to need a transformer to get the voltage correct. And what else? I think that's it. Alright. So, first off, solar panels need to be grounded the same way as batteries. You ground them wrong, you will blow them up. Same way as batteries. The little blue dot down there is the negative. The red dot is positive. Always remember red is positive. Same thing with the battery. If you put a positive to a ground, you will blow it up. Also with the same thing as batteries, solar panels have cumulative voltage. This doesn't show, but 14.7 volts times 4 is about 60 volts. The reason we have the transformers is because we need to transform it to 200 volts for our base's voltage. So transformer here, transformer here. Going to need some more solar panels on the other side. Oh, don't hook them up backwards. You will be sorry. There we are. And let's add a solar tracker upgrade to all of them so they get the optimal power. If they follow the sun, they do better. Plus, it looks cool to watch the solar panels move as the sun sets. Alright. Finally, we have to put the cables in the transformers. Now remember, since we're stepping up the voltage, the yellow side needs more cables than the green. I'm going to put 1 cable in the green side and 4 in the yellow. Need a ferromagnetic core too. Knew I was forgetting something. There we are. And a core. Same thing here. We need 1 in the green, 4 in the yellow, and a core. Now here's where you get out your handy dandy meter and double check your measurements. As you can see, it goes to 236 volts. That's not bad. You have 59 volts, which is 60, to 236. That won't blow up your 200 volt cables, even though it does seem like it'd be high. Hook that up. That is also 236. That's just fine. These can hook together. And let's put them down to the basement. Whoops, I went one too far on that. That should be down this hole. There we are. Alright. Down, down, down. Now to cover holes, you want to hold the C key and right-click. Same thing here. In this case I need dark oak wood. Again, hold the C key and right-click. Back downstairs. Hold the C key and right-click. And then go down to the basement. Now, I forget exactly where that comes in. Oh, right there. Alright. So now we are powered by solar energy. As you can see, there still is power going into the batteries. Also, the turbines are off, so all that power must be coming from that solar line. As you can see, 502 watts is a pretty hefty amount. Note, though, that that's only going to work in the daytime, so when nighttime comes, you'll get bo diddly. An alternative to that is to use wind turbines. This field over here seems like a pretty good place to keep them. So those guys... Where is my wind turbines? There we are. So I'm going to use those. Now wind turbines use about 50 volts, so I'm going to need some low voltage cables in this case. And just place them around here in a decently looking fashion. And far enough away that you'll get good use out of them. Alright. Those. Also note that you can only hook onto the back of the wind turbines, so if you think it's not working, put the cable somewhere else. Alright. Now since those are at 50 volts, like the solar panels, we have to transform them up. 1 cable goes in the green, all 4 cables go in the yellow. Again, you need another core, which is here. Put it in there. And also check your measurements. 236, that's just fine. So then take those 200 volt ones and run them over here. Alright, now I think this is where I need to go down. There we are. And go down in the basement. While I'm down here, let me put these machines to use. Since they aren't doing anything right now, here is some coal. Throw that in the macerator. Right now he's using 413 watts. That is not horrible. Those batteries can easily provide that much power. Also note that the power in just rose. That is because these turbines started producing power because the voltage got too low. Actually put something there, I think. Maybe, maybe not. Where is my little voltmeter dial? There we are. Analog VU meter. So I take this guy and put him there instead. I can break that and put an analog VU meter right there. There we are. Now that'll show us how much the turbines are on. As you can see, they're running pretty decently right now. Anyways, let's get those lights hooked up. Or, not lights, wind turbines. Again, that's 236 volts. That light is 213. That should not cause any problems. There we are. So right now the wind turbines are producing about 100 watts. It's not a bunch, but it's enough to get some lights going. Cover that up. Make sure I didn't cover anything important up, and we're still good. Alright. So, let's go light the other floors. As you can see, it's pretty dang dark up here. So let's see. I like the simple lamp sockets for these type of ceilings. Just sort of guess where they need to go. There we are. Now these I'm not going to run cables to because I want to turn them on and off. I'm going to say this should be F1 for floor 1. Again, it does need a cable no matter what, and it's going to need some light bulbs, and I'm going to also again get the 200 volt economic bulbs. Note that it says F1 is not in range. We'll have to fix that later. Also note that right now this says default channel. However, if you change one of these to a non-default channel, the next one lamp socket you place will have that same channel. It helps if you're placing a whole bunch of lamp sockets at once. Again, powered by lamp supply, F1 is not in range. We'll have to fix that. Back down into the basement. Now we need to get a lamp supply, and if I want to turn them on and off, I'm going to need a relay. And if I want to make it wireless, I'm going to need a wireless signal receiver. Let's get this guy here. And the relay. And a wireless signal receiver. Again, I want this to be F1. Not F exclamation point, F1. And this should be F1, so this should power the lights that are F1. Give him a cable, and you can give him more cables if you want. Those are easily within a range of 32 blocks, so I'm only going to give him one. So, we go back upstairs. F1 is in range now. Now the only thing left to do is get that power to that lamp socket. Going to hook him up to this main line running across the room. And now I need to have a button that has F1. Note that this F1 for all these signal transmitters and receivers is different than the F1 for these lamp supplies and lamps. I keep it the same for the sake of my sanity and knowing what the heck I connect to what. So let's go upstairs and add a wireless button. So you place this guy here. If you hold C and right click, it will let you to choose what channel it is. In this case, that's F1. I'm going to put the same one here at the front door. Again, that should be F1 for floor 1. Finally, you need to go downstairs and configure the relay. Now the relay is good. It should be normally open, which means normally off. Here, though, I want to put this on toggle. It says toggle the output each time emitter's value rises. This is sort of similar to what a button does. In fact, these are the wireless version's buttons. You press it, it stays on for just a sec, and there you go. This way, no matter which switch I press, the front or the back, the lights will turn on, or the lights will turn off. It's like a three-way switch inside most house lightings. Personally, I like how this brightens it up. Makes it look a lot better. This second story, on the other hand, needs a little bit more light. Let's get a suspended socket. Don't need a transformer. Put this guy there, that guy there. Again, this time I don't want him to be floor 1. He needs to be floor 2. He needs a light bulb and a cable. Same thing as before. Light bulb and cable. This time, though, I don't really want to use a wireless button. I want it to be green if that's on. So I'll use a wireless switch. Ah, my bad. Those are stairs. You can't place those on stairs. Again, I'll name this the same as the lamp thing. That should be F2. Green is on. Red is off. Go downstairs and back into the basement. This should be F2 for floor 2. Give him a cable. Again, I need another relay and another wireless signal receiver. Put him on F2. Note, though, that I'm going to leave this as biggest. This means that whenever any switch is on, the relay will be closed and the lamp will turn on. It's different than toggle, and that toggle will only turn on every time there's a toggle. It's a little intricacy. It's not too important. It really just depends on whether or not you want the thing to be on if any switch is on, or only to be on when something gets toggled or button pressed. Anyway, notice how the light's green. That means it sees that switch we put up there on the second floor. Flip that around correctly. Give it one of those. And that light on the second floor should work now. There we go. Also note that rainstorms make those things go crazy. I guess it's the wind. I don't see how there's any wind in here. But anyways. So yeah, now we have a light in our base too. Let's take this coal dust out of the macerator here. I'm going to go put it in the, let's put it in the compressor. I'll leave that to its thing. One other thing you might want to consider is not having these lights on all the way, or all the time. This is actually easy to do with a relay and a motion sensor. So I'm going to take this cable and instead run him across this way. Break that. And break that. Maybe not yet. Can't see down here. Anyways, so I need a medium voltage relay. I'm going to put him right here. I'm going to hook him up to a timer. And I'm going to hook that timer up to a entity sensor. Notice how the timer is red? That means that something has not triggered it. Now that's only 2 seconds. I want this light to stay on for maybe 60 seconds. Then I can put the entity sensor there, so when someone comes down, The entity sensor will trip, that timer will start, and you get 60 seconds of light. Now, I mean, if you move around down here, that sensor will also trip, so that'll stay powered. But what this means is that these suckers won't stay on all the time. They'll only cut on when you're down here. And if you hear them cut on when you're not down here, someone has apparently been tunneling into your base to steal things. One more thing that I like to keep in the basement is a collection of flashlights and batteries. You never know if you'll need them for exploring caves or in case your entire system goes out, so it's handy to keep around. These are pretty easy. You just hook them into any valid power source. So I'll stick this guy, why not there? You can hold C to rotate his supply line. Put the battery, and there is on. This machine booster, go into that later. And those guys will start charging. They'll turn green when they're fully charged. Alright. Now we've done wind power, we've done solar power, so we've got plenty of power here. We've got our machines running, we got our batteries running, and we got our lights on. Let's run these cold plates through here again. Now the only other thing we can really do is convert these furnaces to electrical. I mean, if you're going to have an electrical age house, you might as well get some high quality furnaces that reflect your prestige. So let's get an electric furnace. I'm going to need a heating element. I like to not keep them too high. You can get like a big old whopping 1.2 kilowatt one, but that puts stresses on your system that it really doesn't need. I think in this case 400 watts is good. That way if your generators run out of coal and you simply pull from the batteries, you won't overstress them and cause them to overheat. So, stick that guy there. Let's give him a medium voltage cable again. Nope, I don't want to cook those. Oh, my bad, this doesn't get that. It's one of those. Auto shutdown is off. That means unless I give it food, it won't turn on. It currently has 0 volts as a supply. We need to fix that. That's in the way of my hopper system. That can be fixed. Assuming... Okay. Let's put that over here. There we are. I'll wire that to go down this way and just hook that down into this line. I don't want that to hook to that one, but maybe that's what I'm going to have to do. Anyways, so cover that one up. I do not want it to go this way, so how can I fix that? I can always put a hub there. I find hubs are useful for keeping these cables from going the way you don't want them to. If you click on the little lines here, it will redirect your cables. No, don't want it that way. There we are. So put that there, put that there. There we are. That'll keep this power cable from feeding into this lamp circuit when no one's down here. And it allows us to have that there too. Alright. Back upstairs. That doesn't have any voltage. Why not? I probably did not hook something up correctly. That's just fine. That's just fine. That is 200 volts. 200 volts. 200 volts. 200 volts. 200 volts. Ah, the heating element came out of it. There we are. Now it's 206 volts. Takes a little bit of fiddling to get this electrical age stuff right. Anyways, so we've got our lights, we got our solar power, we got our wind power, which actually spins faster during rainstorms like these, so that's kind of a bonus. You lose some from solar, you gain some from wind. You got charged up batteries, got everything you could want, including diamonds. Bet you didn't see that one coming. Anyways, if you want to make diamonds in electrical age, you can. You take your coal, you macerate it into coal dust, take the coal dust, you compress it into a coal plate, then you take the coal plates and compress them even further into diamonds. Now, if you're like me, you've got tons of coal lying around and have stopped mining the suckers looking for diamonds, so you can throw some of that extra coal into furnaces and whatnot, throw some of it in here in the macerator, and actually get what you're looking for. Saves you some time on mining, and it's cool to say that you can make diamonds. Only drawback is it takes a long time to produce, which means it takes a lot of power and a lot of energy. So keep that in mind. Anyways, that's about it there is to building bases. Join me next time when we talk about factories and other cool stuff. This is Don Bruce, signing off.